In this video, we will discuss correlation in statistics. If we denote petrol consumption by X and mileage given by the vehicle by Y, then we find that there is some relationship between X and Y. But if we compare rainfall figures denoted by X with production of cars denoted by Y, then we see that there is no relation between X and Y. This relationship involves two variables X and Y. Therefore, such relationships are known as bivariate correlations. Here, if X changes, Y also changes in the same direction or in opposite direction. Therefore, correlation is study of existence, its magnitude and direction of variation between two or more variables, or in this case between X and Y. So this is what is known as correlation. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. In the second type of correlation, which is linear or non-linear correlation, is based on the nature of the graph of the relation between the variables X and Y. In the graph of variable X versus Y, if the graph is straight line, then the correlation is a linear correlation, and if the graph is not a straight line but a curve, then the correlation is non-linear or curvilinear correlation. Correlation of bivariate data is studied in following methods. First method is scatter diagram, second is Karl Pearson's coefficient of correlation, and third is Spearman's rank correlation coefficient. In the first method of scatter diagram, to study the correlation between two variables, a scatter diagram is constructed. For this, one variable is plotted along the x-axis and the other along the y-axis on a graph paper. By plotting data in this way, we get points which are generally scattered but which show a specific pattern. The way in which the points are scattered indicates the degree and direction of correlation. For example, in this scatter diagram, the points are close to each other, or in this scatter diagram, the points are also close to each other. Therefore, we say that the variables x and y are correlated. If these points spread away from each other, like in this scatter diagram showing no pattern at all, we say that the variables are not correlated, or they are zero correlated. If the points lie in a narrow strip rising from left hand bottom to the right hand top like this, we say that there is positive correlation between the variables x and y. And if the points lie in a narrow strip falling from left hand top to the right hand bottom like this, we say that there is a negative correlation between the variables x and y. So in this scatter diagram, there is high degree of positive correlation, and in this diagram we can see high degree of negative correlation. If in a scatter diagram the points lie along a straight line from left bottom to the right top like this, then this is known as perfect positive correlation, and the value of coefficient of correlation denoted by R is +1. On the other hand, if the points lie along a straight line falling from the left hand top to the right hand bottom, we say that there is perfect negative correlation between x and y, and the value of R in this case will be -1. The value of the correlation coefficient R lies between -1 and +1. For positive correlation, the value of R lies between 0 and 1, and for negative correlation, the value of R lies between -1 and 0. Here we find that the method of scatter diagram is descriptive in nature and gives only a general idea of correlation, but we are interested in a numerical value of the correlation known as the coefficient of correlation denoted by R, whose value lies between -1 and +1. And the most commonly used methods for finding coefficient of correlation are method number 1, Karl Pearson's coefficient of correlation, and second, Spearman's rank correlation coefficient. Now we will see how we can use Karl Pearson's coefficient of correlation to find numerical value of correlation R. We know that square of standard deviation sigma x square, which is 1 upon n summation x minus x bar whole square, gives us a measure of variation in x, and square of standard deviation sigma y square, which is 1 upon n summation y minus y bar whole square, gives us measure of variation in y. Therefore, we can expect 1 upon n summation x minus x bar into y minus y bar to give the measure of simultaneous variation in x and y. But this depends upon the units of x and y. Now, to find a ratio which is independent of these units, we divide this by the quantities of the same order sigma x and sigma y, that is standard deviation of x and standard deviation of y. Therefore, Karl Pearson's coefficient of correlation R to measure the correlation between x and y is given by R equals summation x minus x bar into y minus y bar upon n times sigma x into sigma y. But here this quantity is known as covariance of x and y. Therefore, Karl Pearson's coefficient of correlation R will be covariance between x and y upon product of standard deviation sigma x sigma y. We have standard deviation sigma x equals square root of summation x minus x bar whole square upon n, and sigma y equals square root of summation y minus y bar whole square upon n, and the product of sigma x and sigma y will be square root of summation x minus x bar whole square into summation y minus y bar whole square upon n. We will write the formula for R, which we have already found. R equals summation x minus x bar into y minus y bar upon n times sigma x into sigma y. Now, in place of this sigma x into sigma y, we will substitute this value which we have found out. So next we write this R equals summation x minus x bar into y minus y bar upon n multiplied by reciprocal of this n upon square root of summation x minus x bar whole square into summation y minus y bar whole square. This n gets cancelled. Now substituting for x minus x bar equals x dash and y minus y bar equals y dash, we write R equals summation x dash into y dash upon square root of summation x dash square into y dash square. Let's block this formula. Now R becomes, in the numerator, summation xy minus y bar into, for this summation x, n x bar minus x bar into, for this summation y, n y bar plus this x bar y bar into n. In the denominator, it will be square root of summation x square minus 2x bar into, for this summation x, n into x bar plus this x bar square into this n into summation y square minus 2 y bar n y bar plus y bar square into n. Now that will be finally r equals, in the numerator, this summation xy minus n x bar y bar cancels with this plus n x bar y bar, and there will be minus this n x bar y bar. In the denominator, it will be square root of this summation x square x bar square n minus 2 x bar square n gives us minus n x bar square into summation y square. N y bar square minus 2 n y bar square gives minus n y bar square. Now in this formula for r, if x bar and y bar are integers, then we take deviations of x and y from them and use in this formula. There are three methods of calculating r. The first is actual mean method, step deviation method, and third is assumed mean method. So first let us see actual mean method, and formula for this method is r equals summation xy upon square root of summation x square into summation y square. Here x is deviation of x from mean x bar, that is x equals x minus x bar. Similarly, y is deviation of y from y bar, which means y equals y minus y bar. To calculate this r, we have to prepare a table in which we calculate all these values and substitute them in this formula and calculate r. So let's see how we can do it. We have to find the degree of correlation or the coefficient of correlation r from the data in which demand in quintals x is given as 65, 66, 67, 67, 68, 69, 70, 72, and the corresponding values of price in paise per kg y are 67, 68, 65, 68, 72, 72, 69, 71. We will prepare a table in which the first column is serial number, the second is demand in quintals x, which is calculated as x equals x minus x bar. Then in the third column, price per kg y, which is y equals y minus y bar, and the fourth column is product of quantities. So first we will write values of x. From here we get summation of these values of x 544. X bar will be summation x 544 upon number of values 8, that will be 68. Similarly, we will write values of y from here and write summation of y equals 552. We find y bar equals this summation of x 552 upon number of values of y 8, that will be 69. The serial numbers will be 1, 2, and the value of n will be equals 8. Next we will write the values of x which will be obtained by x minus x bar. So the first value will be 65 minus 68 minus 3, and the rest of the values will be, next column will be that of x square, so we write 9, 4. Summation of x square will be 36. Next we find values of y, which will be y minus y bar. Please correct this mistake. So the values of y will be 67 minus 69 minus 2, and summation y square will be 44. Next we have to write the product of this x and y, that will be xy, and the first value will be 6, and summation xy, that is sum of all these numbers, will be 24. According to the formula of actual mean method, we write r equals summation xy upon square root of summation x square into summation y square. By substituting the values, we get r equals 24 upon square root of 36 into 44, that equals 24 upon 39.80. So finally we get the correlation coefficient r equals 0.6030. Now let us interpret this value. If the value of r lies between 0.40 and 0.60, then it means there may be some relationship between x and y, but the value of one variable calculated from a known value of the other variable cannot be reliable. So this is the inference that we can draw from this value of r here. In the next problem, we will calculate Karl Pearson's coefficient of correlation R for the bivariate data given as the values of x 28, 45, 40, 38, 35, 33, 36, 33, and the corresponding values of y are 23, 34, 33, 34, 30, 26, 28, 31, 36, 35. We will prepare a table in which the first column is serial number from 1 to 10, then the value of x, that will be x minus x bar, and the value of y will be y minus y bar, and finally product of x and y. Here first we write the values of x, which from here are, the serial numbers will be 1, so that n will be 10. Summation of x will be 360, which we use here to find x bar, which is this summation x 360 upon this n, which is 10. So x bar is 36. Next we write values of y. From here 23, summation of y will be 310, so that y bar will be summation of y 310 upon n, which is 10, so it will be 31. Now we write the values of x from x minus x bar, that is 28 minus 36 minus 8. Similarly, values of x square will be 64, and summation of x square will be 216. From the values of y and y bar, we will find the values of y. Those will be 23 minus 31 minus 8, and y square will be minus 8 square 64, and summation y square will be 162. Next we write product of x and y, that will be 64, and summation xy will be 97. Now we will use these values to find r. So we write by actual mean method, r equals summation xy upon square root summation x square into summation y square. So that will be r equals 97 upon square root 216 into 162, which is 97 upon 187.1. So finally r will be 0.5186. We will interpret this value of r. Since r lies between 0.40 and 0.60, means that there may be some relationship between the two variables x and y, but the value of one variable calculated from a known value of the other variable cannot be reliable. So this is the inference that we can draw from this value of r. In the second method of calculating coefficient of correlation, we use the step deviation method. Step deviation method is used to further simplify the calculations which need to be done in the tabular form. So let's see how step deviation method is used to calculate the coefficient of correlation. So here we will consider a data in which the values of x have been given as 100, 200, 300, 400 and 500, and the corresponding values of y are 30, 40, 50, 60 and 70. In our table, the first column is serial number. In the second column, we write values of x from here 100 and the serial numbers. So we have n equals 5 and summation of x equals 1500. Next we write x bar equals summation x upon n, that is 1500 upon 5, 300. And next we write the value of x as x minus x bar upon the width of values of x, that is 200 minus 100, 100. So from this we write 100 minus 300 minus 200 upon 100, that will be minus 2. Next, 200 minus 300, that will be minus 100 upon 100, 1. Similarly, we write 0, 1, 2. Our next column is x square, 4. Summation of x square is 10. After this, we write values of y from here 30, 40, 50, 60 and 70. Summation y will be 250, from which we calculate y bar. That will be summation y upon n, that is 250 upon 5, 50. Next, we write value of y equals y minus y bar upon width between the values of y, which is 10. So upon 10. So the values of y will be 30 minus 50 minus 20 upon 10 minus 2, 40 minus 50 minus 10 upon 10 minus 1, so on and so forth, 0, 1, 2. Next we write values of y square, that will be 4, and summation of y square will be 10. And finally we have to write product of values of x and y, and this product will be minus 2 into minus 2, 4, 1, 0, 1, 4, and that gives us summation xy equals 10. Now we have r equals summation xy upon square root of summation x square into summation y square. So we write 10 upon square root of 10 into 10, that will be 10 upon 10, or r will be 1. Value of r equals plus 1 suggests that there is perfect correlation between x and y, and its scatter diagram will be a straight line from left bottom to right top. Now we will discuss the third method, assumed mean method. In the earlier two methods, actual mean method and step deviation method, we were using mean x bar, which is summation x upon n, and mean y bar, which is summation y upon n, and we used to take deviations to find x equals x minus x bar and y equals y minus y bar. But in these cases, suppose if x bar and y bar is not an integer, then taking deviations x minus x bar and y minus y bar would become tedious, and finding x square and y square would become more tedious. So in order to simplify the calculations, we use assumed mean method, in which we assume some convenient value of x and in case of y as the assumed mean, and then take deviations dx equals x minus the assumed mean and dy equals y minus the assumed mean. This simplifies the calculations, but we need to write the revised formula for r in terms of deviations dx and dy as r equals summation dx dy minus summation dx into summation dy upon n upon square root of summation of dx square minus square of summation dx upon n multiplied by square root of summation of dy square minus square of summation dy upon n. So by using this modified formula for r, we can find Karl Pearson's coefficient of correlation. We will see one example and find out how the calculations are simplified by using assumed mean method. We are going to find the coefficient of correlation for the prices in rupees and the sales units. The bivariate data given is, we denote price in rupees as x, and the values given are 100, 98, 85, 92, 90, 84, 88, 90, 93 and 95, and sales units by y, and the values given are 500, 610, 700, 630, 670, 800, 800, 750, 700 and 690. In case of price in rupees, x, x bar will be summation x, which is 915 upon number of readings 10, gives us x bar equals 91.5, which is not an integer but a fraction. So to calculate x, we have to find x minus 91.5, which is going to be bit tedious, and x square will also be more tedious. So to overcome this difficulty, we use this assumed mean method. So let us prepare a table for assumed mean method. So serial number, then price in rupees. The values of x will be from here 100, 98, 85. We will assume 92 as the mean and find out deviations dx by calculating x minus 92. So that gives the values of dx as 100 minus 92, 8, 98 minus 92, 6. That gives summation dx equals minus 5. Next we find dx square, that will be 64, 36, and summation dx square will be 247. Next we do similar calculations for cells units. For that, first we write values of y from here 500, 610. Here we assume 670 as the assumed mean and calculate dy by y minus the assumed mean 670. So we get values of dy as 500 minus 670 minus 170, 610 minus 670 minus 60. We get summation dy as 150. Next we will calculate dy square. Minus 170 square is 289.00 and summation dy square will be 76500. Next we will require product of dx and dy. So we write dx into dy in this column. So it will be 8 multiplied by minus 170 is minus 1360. 6 into minus 60 minus 360, and summation of product dx dy is minus 3560. Let's write the serial numbers so that n is 10. Let us rewrite the values to be used in the formula. We have summation dx dy equals minus 3560. Summation dx is minus 5. Summation dy is 150. N is 10. Summation dx square is 247 and summation dy square is 76500. Now we will use these values in the formula for r, which is summation dx dy minus summation dx into summation dy upon n upon square root of summation dx square minus square of summation dx upon n into square root of summation dy square minus square of summation dy upon n. Now we will substitute the values and write minus 3560 minus 5 into 150 upon 10 upon square root of 247 minus 25 upon 10 into square root of 76500 minus 22500 upon 10, that will be minus 3560 plus 75 upon square root of 247 minus 2.5 into square root of 76500 minus 2250. That will be minus 3485 upon square root of 244.5 into square root of 74250. That will be minus 3485 upon 4261. That finally gives r equals minus 0.8179. Now here r lies between minus 1 and 0, and it is near to minus 1, which means that there is a high degree of negative correlation between x and y and its scatter diagram would look like this. Let us solve one more problem by assumed mean method. We have the bivariate data in which values of x are 23, 27, 28, 29, 30, 31, 33, 35, 36, and 39, and the corresponding values of y given are 18, 22, 23, 24, 25, 26, 28, 29, 30, and 32. Let us prepare a table for calculation. So first column is serial number, then values of x, which are from here. First 23, second 27, here n is 10. We assume 30 as the mean of x and write the values of dx from x minus assumed mean 30. So the values of dx will be 23 minus 30 minus 7, and summation dx will be 11. Next we write dx square, that will be 49, 9, and that gives summation dx square equals 215. Next we write values of y from here. 18, 22, we assume 25 as the mean value of y, and from y minus 25 we will write the values of dy, which will be 18 minus 25 minus 7, that gives us summation dy equals 7. In the next column we write dy square, so that will be 49, 9, and that gives us summation dy square equals 163. In the last column we write product of dx and dy. So minus 7 multiplied by minus 7 is 49, and we get summation dx dy equals 186. Now we will rewrite the values to be used in the formula for r. They are summation dx dy equals 186, summation dx 11, summation dy 7, n 10, summation dx square 215, and summation dy square 163. We have formula for r. Now we will substitute the values. The final calculation gives the value of r to be 0.9948. This value is very close to 1. So we conclude that there is nearly perfect correlation between x and y, and the scatter diagram will be almost a straight line from left bottom to right top. Now we will see how we can use the values of x and y directly to find coefficient of correlation r. So now we will see direct method to find r. The formula for finding r directly from the values of x and y is summation xy minus summation x summation y upon n upon square root of summation x square minus square of summation x upon n multiplied by summation y square minus square of summation y upon n. We will use direct method to calculate r for the bivariate data given as follows. The values of x given are 3, 5, 4, 6, 2, and the values of y are 3, 4, 5, 2, 6. We will prepare a table of x, x square, y square, and xy. Values of x 3, 5, 4, 6, 2, x square 9, 25, 16, 36, 4. Values of y 3, 4, 5, 2, 6. Y square will be 9, 16, 25, 4, 36. Next we write xy. So 3 3s are 9, 5 4s are 20, 4 5s are 20, 6 2s are 12, 2 6s are 12. We get summation x 20, summation x square 90, summation y 20, summation y square 90, summation xy 73. Substituting the values in this formula for r, we write r equals 73 minus 20 into 20, 20 square, n is 5 upon square root 90 minus 20 square upon 5 multiplied by 90 minus 20 square upon 5. That will be 73 minus 80 upon 10. So we get value of r equals minus 0.7. Now since value of r is between minus 1 and 0 and it being close to minus 1, we say that there is high degree of negative correlation and the scatter diagram will be like this from left top to right bottom. We have to find correlation coefficient r between x and y, where we are given data in the form of n equals 10 summation x equals 140. That will mean x bar equals summation x 140 upon n 10, that is x bar will be. Next, summation y equals 150, that gives y bar equals summation y 150 upon n 10, so that gives y bar equals 15. Next we are given summation x minus 10 square equals 180, summation y minus 15 square equals 215, then summation x minus 10 into y minus 15 is 60. Now here with usual notations we write summation x minus 10 whole square equals summation dx square equals 180. Then we write summation y minus 10 whole square as summation dy square equals 215, and this summation x minus 10 into y minus 15 we write summation dx into dy equals 60. Now we have x bar equals this assumed mean 10 plus summation dx upon n. Therefore we write x bar equals 14 equals 10 plus summation dx upon n equals 10. So that gives summation dx equals 4 into 10, 40. Similarly, we write y bar equals this assumed mean 15 plus summation dy upon n. Therefore, y bar equals this 15 equals 15 plus summation dy upon 10. That gives summation dy equals 0. Now we write formula for r. After putting the values, that will be r equals, which finally will be 0.915. Since the value of r is between 0 and 1 and it being near to 1, there is probably a definite relationship between the variables x and y, and the value of one variable can be roughly estimated from a known value of the other variable. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.